everyone, good evening. This is Y.Renuka from 4th ECE bearing roll number 19BQ1A04H5, and now I am going to discuss about radar block diagram and its applications from subject radar engineering. Radar block diagram. Radar block diagram consists of elements like pulse modulator, transmitter, duplexer, antenna, and a low noise radio frequency amplifier, mixer, local oscillator, IF amplifier, 2D detector, video amplifier, and finally a display. There are two sections of radar block diagram. First one is the transmitter section and second one is the receiver section. Under transmitter section we have transmitter. The transmitter may be a power amplifier such as klystron, traveling wave tube, or transmitter amplifier. This will generate the electrical energy at radio frequency. Pulse modulator. The power amplifier produces a high power signal, maybe in terms of megawatts. Pulse modulator shown in the block diagram is used as a switch which will turn on and off the power amplifier. Waveform generator. A low power signal is produced by the waveform generator which is given as an input to the power amplifier. Duplexer. The duplexer allows the signal antenna to be used on a time shared basis for both transmitting and receiving. The duplexer is generally a gaseous device that produces a short circuit as an input to the receiver when the transmitting is operating. That the power flows to the antennas and not to the receiver. On reception, the duplexer directs echo signal to the receiver and not to the transmitter. In receiver section we have low noise RF amplifier. The receiver is almost always a super heterodyne. LNA is used immediately after the antenna. This reduces noise figures and produces the RF pulse proportional to the transmitting signal. Mixer and local oscillator. It converts the RF signal to an intermediate frequency where it is amplified by the IF amplifier. The IF frequency might be 30 or 60 MHz. IF amplifier. IF amplifier amplifies the intermediate frequency. Intermediate frequency amplifier is designed as a matched filter which maximizes the output peak signal to the mean noise ratio. The matched filter maximizes the detectability of echo signal and attenuates unwanted signals. The signal bandwidth is super heterodyne. Receiver is determined by the bandwidth of the IF frequency stage. For example, when pulse modulator pulse width of is of order 1 microsecond and the of IF bandwidth would be 1 MHz. Second detector. The IF amplifier followed by a crystal diode is called second detector or demodulator. Its purpose is to assist in extracting the echo signal modulation from the carrier. It is also called as second detector since it is the second diode used in the chain. The first diode is used in the mixer. Output of the second detector is the video pulse. Video amplifier. It is defined to provide the sufficient amplification to raise the level of the input to be magnitude where it can be displayed. Threshold decision. The output of the video amplifier is given to the threshold detector where it is decided whether the receivable signal is coming from an actual target object or from the noise. Display. The display is generally a CRT, that is nothing but cathode ray tube, and it has of different types: A scope, PPI. A scope gives the range and echo power. PPI measures the range and bearing angles. In addition, there are other displays like A scope, B scope, and D scope. The first figure A shows us about the A scope, and the second one gives the idea about PPI scope. And finally, while coming to the applications of radar, there are many daily life examples of radar which we are using in, and some of those are applications of radar comes under military. In military purpose, we use application of radar and remote sensing, air traffic control, law enforcement and highway security, aircraft safety and navigation, ship safety, space, and miscellaneous applications. Military comes under we can know the position of the missile and we can react as per the position of the missile. And in air traffic control, we can know about the weather conditions and the air traffic control of different airplanes and in the place of airports. Law enforcement and highway, it comes under to control the speed of the vehicles on the highway and etc. These are the applications of radar. And finally, thank you.